Machine learning for prediction on the basis of decision forest regression model. Hi, this is Devansh. Welcome to this session. I will be training you how to create a machine learning model to predict what could be the price of a house on the basis of the data that we have that is available to us. Start with, let's add the data. Let's choose Austin. We will be predicting data of market. It will be a regression-based machine learning model to predict. This is not a new version of an existing data set. Okay. Uploading the CSV file. It is uploaded. Now let me create a project. Regression model to predict Austrian property price. All right. Now what we can do is we can go to data. I can connect this data to the project. In the last session, we had created a supervised classification ML model to predict whether a person will survive or not in an accident. This time we are going to build a regression-based model to predict what will be the property price. Click OK or check mark. Let's go to create the experiment. Now we already have so many experiments. We have to click on new experiment. I need to add the data. Okay, data is already there. Experiment. Let's call this experiment as Austrian property price. For our understanding, I can write regression. That's all. I think that is fine. Now, okay. It's a little long name. Let it be. Now let me save it. Cannot save it. Okay, cannot save the experiment because there's no modules. Let us at least add the data. Data is right here. Now let me save it. Now I can visualize the data. What's the address of the property? How many rooms does it have? What type of property it is? Price, method, how it was sold. Who was the seller? Date when it was sold. 58 unique values. In a data set where we have 30,000 rows, it means the price is, the time frame is not widespread, otherwise we could have used it. Distance, it's pretty good. I think this distance from the market. Postal code of the property. How many bedroom does it have? Bathroom, car park, land size, building area, year, how old it is. Council, 33 unique values. It's a string feature, so we have to convert that into categorical. Longitude, latitude, region name. 8 unique values, so we have to convert this also into categorical. And property count. Now, let us add some. Let's see the summary of the data. Okay. What I can do is, let us remove the data that we don't require. So it has already deleted suburb and other suburb address. Now suburb address we have. We don't require this data. Let us select the columns. Do we see data manipulation? I can increase or decrease the size over here. Manipulation, select column in dataset. Now what I have to do is, I need to delete this, connect this to this, and then summarize. But for this I need to launch the column selector. And what I don't, let me select all. And then I don't need suburb, I don't need address, and the method by which it was sold. Rest all I need. Room, type, price, seller. Do we need seller? We'll take a look. Date, distance, these all are numeric. This is good. Let me click on OK. Now let me run it. Now let me click on visualize. Okay, we have room. Okay, we require room. And what I see is we have missing values in this 4 data: car, building, year, and council. Okay, but before we go ahead and add the missing values or impute the missing values, what I have to do is I need to change. Let's take a look. I need to change the string data into categorical data. Now some of this data is not this type, this is string, so this type we have to change, and not this fine. Seller, who is the seller? We don't require this data. 268 unique values. Let us go ahead and remove the seller as well. Now click on OK. Now I need to seller could have influenced the price of that property. Anyways, we removed it. Now visualize one more time. So this we have to change type and price, date, distance, bedroom, car, land size, year build, council area we have to change. Year build is numeric, fine. Council area is 1. Region name we have to change. Council area, region name, and 1 we had in the starting. Type. Okay. Add this. Selector. So, council area, region name, and type. These 3 are string, and we need to change into categorical. Now what we have to do is we have to impute the missing value. So to impute the missing value, clean missing data. Connect it and go to summarize. We need to run it. So how many do we have? We have missing value. We have it car, building, year, and council. Car, build, council. So this we will be removing the entire row itself, but only for car. What we will do is we will impute the new values. So let's do it for the car first. Okay, I need to run it. Show in the drop down, otherwise I have to type and do it. You can do it both ways. Launch column selector by name, put it back, put it car. What you want to do is let this be 0 and 1, because if it is 0, even if it is like, even if one value is missing, it will impute. Even if 100% is missing, it will impute. And let's replace it with mean. And saving. Now let me run only this. Now let me add another clean missing data. Connected. And this time what we have to do is we have to, I forgot. Let's click on visualize. So we had car, see car, now it's showing 0. Wait. Missing values here. Car it's 62. Building area, year built, council. Building area, year built, council. This will come here. Okay. And run selected. The reason why it was still showing 62 over here in the summarized data, because we were checking the summary of directly from here. Now, if you will visualize this, let's visualize for car, missing value 0, building area, missing value 0, area built 0, council is 0. Now let's click on save. Now what we have to do is we have to split this data into 2 parts. Training data and test data. So pull up the split module, connect this, and we will split at 70-30. Random seed 1 will not have a certified sampling, so let that be as false. Random seed 1 so that we always have the same sample, and Now, the algorithm that we have to imply or we have to implement is regression. Let me put that, initialize model, that's regression, decision forest regression, pull it up. Now let that be here. And I need train data right here. How will I train the model? And then I will have to score the model. And then I will also have to evaluate right here, evaluate the model. Let me reduce the size of this, not anything else. Okay, so we have Austin. I'm just trying to, let me shrink it so that we have a better view. Plain missing data, split data. So how will we train? To train, we need data, 70% of our training data, and we need the algorithm on which we are going to train. Once that is done, but we are going to train for what? We are going to train to predict the price. Okay, it will not show because I have to. I can right click also and select launch column selector. This is not showing up. Give me 1 second. Let's connect core model and evaluate. Let's run it. Select price here. Problem. Bagging single parameter, it is correct. Split data. Oh, great. When we are training our model on 70% of the training data and on the algorithm, this trained model from here will get into the score to score the model. But to score the model, to run the model on the test data. So we have to connect this here. Otherwise, how will the score model understand that on what data it is going to run, or on what data it is going to score the model that is built at train model. Now this is done. Now we need to click on run. It will take a while. Now it has run. Run selected. Let's run this. It will take a while. Okay, this is already done. So let me recollect what all we have done. We added the data, then we added the module to select only the data that we required. Then we added the module to summarize the data. We checked where all we have the missing values. Then we use edit metadata to convert the string data into categorical data. Then we clean the missing data. We cleaned it for car. Then we cleaned it for building area, year built, and council area. One mistake that I did is the cleaning mode is I want to remove the entire row. Wherever data is not available, as I had said, we will remove the entire row. Now let me run this selected. Now our machine learning model has run. So it is important to revise. You see, I found a mistake. So edit the data, remove the unwanted column, change the data from string to categorical, clean the data, missing value imputed for car, missing value imputed for. Here we did not actually impute the missing value. We deleted all the rows where the data was missing for 3 of this data set: building, 3 of these columns, building area, year built and console area. And then we added the algorithm, decision forest regression. We trained our model on 70% data, then we scored it using the trained model on the test data, connecting this to this, split it, test split data to score model, and then we evaluated. Now this is ready and we can actually deploy this. But before we deploy, we need to check how it is working or what is the accuracy of the model. Now, 2 things that we have to look at is root mean squared error. Mean absolute error, it is 172890. Let me copy this. And relative squared error is 21, relative absolute error is 36. So what does this mean, relative absolute error? It is from 0 to 1 or 0 to 100 in percentage wise. This is 36% absolute error. Mean absolute error is 172890. Let me copy this. Now what does it mean is, we have, let me show you. Let me delete this. Oh, not have done that. Let me download this data. To download this data, I need to convert the data into CSV format. So if you see, if I want to download the data, I can't. I can save this as data set. Even here, I can save this as data set. So I need to convert, I need to do the data transformation. We look for data transformations right here. And I don't see convert to CSV. I can tell you easier way, because you will be struggling sometimes, just like me, by finding the right module. It's not here. So easier way is just write CSV. Data format conversion. Okay. So just add it over here. Increase this length. Connect this to this. Selected. It's running. Now I can download the data. Just right click and download. I have already done that. And this is the data that I have downloaded. Let me download it just to start afresh. Right here, let me click and open this. All right. So this is the data that we have. Now in this data, I see the last is property count, region name. This doesn't look like the right data, because if I go here and visualize, after property count, I should have this data and this data as well. Score level mean and score level standard deviation. This is my actual data, the predicted data. The price is this For this row, the price is this 16940 and the predicted price is this. Now, what I did, I connected this to convert that into CSV so that I can download. Though I did download, it seems to be not giving the right data. Let me do it one more time. Let me download. On the desktop. Now, opening. And this seems to be the right data. We have score level and score level mean. Let me click on save and let me cut price and drop it right here. And I don't need this data. Let me put it aside. So we will be focusing on price and score level. Okay. Now let me go to the experiment and let me show you. Till now we have not done the visualization of evaluate. Like we have not seen what's evaluation. So no, I think we had seen. So 36% was the relative absolute error and mean absolute error was 1728. Let me show you how did we arrive at that. So let's take, let me write here mean and sum. Average price of this forward equals sum. Okay. Now let us see what is the deviation equal ABS division between this minus this. The reason why I wrote ABS so that we always have a positive value. And let me write it deviation from actual price. Okay. Now deviation from actual price is 17891. If I take the mean of deviation from the actual price, this is that data 172890, 172891. Actually, if you just bring it to 0 decimal, it will be the same number 17289, 172,891. So what is like how much deviation do we have? I can take this divided by mean of this into 16%. So with a division of 16%, we are predicting our prices. And if we look at the relative absolute error, and if I take the difference from price, so equal, so again I want real number, like always positive number, and let me freeze it by pressing F4, bracket close, and so let me put this down. Now if I divide this divided by this, sorry, this is a number. So if I divide deviation from actual price by deviation from the actual price, then we are getting the error, which is 36.9677. So let us recap. We have price and we have score level. We took the deviation from each point and we see that this is the deviation that we have. Now, when we see what is the deviation from the actual price, we get the error, and this is that percentage of error that we have, 36.967. Now, we will be deploying this model, but we have to make sure that we have to make sure that this is the right model that we are going to deploy. So how do we make sure that this is the right model? So what we will do is we will try to hyper tune that. And if during the hyper tuning we find that we have lesser deviation, our error has reduced, then we will go ahead and deploy our next model. So let me catch up with you in the next session where we will be doing the hyper tuning of this machine learning model. Thank you guys. Hi everyone, welcome back to this session. So we learned how to create a machine learning model based on decision forest regression to predict price of a house for continuous data. Now, as we see that we have certain accuracy of this particular model that we have built, but let us check if we can improve the accuracy before we go ahead and deploy this machine learning model. Now, one of the things that we checked in when we were dealing with the data, we saw that there were 15 parameters, 15 features in this data, right? When we predicted the house price. What if we can reduce some of the features in case if it can improve the accuracy of the model? Now to do that, let us make certain changes in our machine learning model that we have already built. Let me create a copy and I will name that as to our second ML model. Now, as I pointed out, we had too many features in the starting. Let us reduce the number of features, but we need to take a statistical approach. When we build this machine learning model, what we did, we removed 2-3 parameters which we could easily make out that it was not helpful or it was not beneficial for the model. We removed that, but we did not take a scientific approach. Now, on the remaining parameters, let us take approach of filter-based feature selection. Now, I need to create some space for this. Let me delete this connection and let me make it a little more. I think that will look better. Let me create a connection like this and let me connect this. For feature-based selection, let this be Pearson correlation. Column selector. Okay, I need to run it. Let's run selected only. Let's select this. Let's add price. The checkbox. Number of desired features. Let's pick all. Okay. Let's pick all. We had 15. Let's run selected. Take a while. You see as and when it is getting completed, we have a check mark. It's running this. Now it is completed. So what we have to do is, as we added this module of filter-based feature selection, let's go to this second button and go to visualize second output. And we see that we have all the parameters over here and it gives us the correlation with respect to price. Now, I don't want to get into the detail of statistics, but anything below 30% seems to not have any kind of good relation with price. So why should we have that in our model? So what we can do is let's take account of all the parameters which are relevant and let's only include them. 1, 2, 3, 4, 5, 6, 7, 8. So we'll include in only 8 parameters. So filter-based selection, let's include only 8. Now, as we have only 8, let me run it all once for. It'll take a while. Now it has finished running. Now this is our second model, and let's go ahead and visualize the data. Okay, mean absolute error is, let me copy this, and I have this Excel where mean absolute error. Second model we have 21, earlier it was some 17 something, right? And relative squared error is, and relative absolute error, just bear with me. Let's take a note. This is 0.45, this is 0.29. 0.45, 0.29. Now let me cross this. Relative squared error is 0.29. Cross this. Let me save. It says saving. Done. Let me go to experiments. Let's open the first one. And let's visualize this. I need to run this before I visualize. Run selected. Give it a moment. Now it has run. Let me visualize. So model 1 says 17289. 17289. Let's make it 1. So this was better. And relative absolute error was 0.36. And square error was 0.21. So of course this model is a better model. Now let us do one thing. Let us create a third model. But I will not be doing it in this session. I'll see you in the next session. All right, guys. Hope you enjoyed. If you want to review, you can just take a look. We added the data. We selected the column. We changed the data character from string to categorical. Then we cleaned the missing data. Then we cleaned the entire rows for certain parameters which did not have, which had too many missing data. Then we split the data into 70-30. Then we use decision forest regression algorithm to train our model on 70% data. Then we score the model using our test data. And then we did the evaluation. In the second model, what we did, after cleaning the data completely, we did a filter-based feature selection. And we saw that if we remove a couple of features from our entire model, the accuracy has slightly reduced, correct? Okay, in the next session, we'll create another model. Actually, we will refine this model. The third model we will create to predict price. Thank you so much. Hope you enjoyed. Bye-bye. Hi all, welcome back. So we are going to refine it for the third time, our machine learning model that we have built on a regression model to predict the price of the house. Now, in this case, what we are going to do is we are going to use the hyperparameter tuning model. But first and foremost, let me create a copy of this. As we saw that our second model was not good, so we will go ahead and use we'll create a copy of the first one itself. Save it as the third one. Okay, now that we have it, what we are going to do is we are going to add, we don't want this, we are going to tune model hyperparameters, and the data will come from here, split data. What's the algorithm is going to run? It's going to run decision forest regression itself. The data it is going to take is 70% data. like this. And now this looks better. And we will have one score model, which will have entry of our score model hyperparameters. But why it is not connecting? Give me a second, let me check. Oh, this is the trained best model. This is the output. So we connect the output to his score model, and it's going to score on the split data, which is, split data, the test data, which is coming from here. And I connected it like this. Don't get confused with the spider kind of figure. And I'm going to use this score model and evaluate here. So I connected this. Now let us run, and it will take a while. Okay, but this red mark is because we need to select let's select the entire grid. Tune on what? We need to select price. Tune for price. Let this be accuracy mean absolute error. This correct. Now we need to run it. It's running. Give it some time. Still running. Still running. 41 seconds. Tune model hyperparameters will usually take longer duration of time, but it will pick up the best model. I think it will take a little more time. Last time I had run the similar model of around 6,000 rows, which had taken around 12 minutes. Let's wait for a while. And it's still running. Let's wait for a while. It has now finally finished running. It took 19 minutes. Let us now, we need not to go for a score model, but we can actually right-click and visualize. So this is our actual price, and this is our predicted price. Now what we have to do is go to evaluate, visualize, and we have 172890. If you remember, this is our first model, and 165921 is our second model. Our root mean square error has also reduced. Our absolute error has also reduced. Our relative squared error has also reduced. So this looks like a better model. The second model looks like the better model, or we can say this is a third model that we are doing. We ran the first one, and then in the second one we did feature selection from here, filter-based feature selection, in which we dropped 7 parameters approximately, and we had only 8 parameters to predict, but then the accuracy declined. And now this is our third model where we added tune bed model hyperparameter. I could have removed this and added only this, but I want, instead of using the Excel and write the data and then match it, this is easier way. Let me save this. Okay, now it is saved. Now, should we go ahead and deploy it? Or should we go ahead and try one more algorithm to check if we can further improve accuracy of this machine learning model? To do that, I'll see you in the next session. Thank you, everyone. This is Devansh. Bye-bye. Everyone, this is Devansh. And this is the second last session in which we are creating a machine learning model based on decision forest regression. And we have already created 3 models, and the third model looks pretty impressive. I have noted down the data over here. So this was the first model. I can write decision forest regression, and then here we added This is decision forest regression plus feature selection. This is just to help us understand how we have progressed. And then we did tune model hyperparameter. Now what we are going to do is model 4. And before we go ahead, let us create a copy of it. Let me save this first. Saving. Now let's save this as 4. Now let us use another algorithm. Instead of decision forest regression, let's use the boosted model. Boosted. Give me 1 second. Boosted tree regression. Now, as I have added this, I'm going to add boosted decision tree in tune model hyperparameter. Or yeah, let's do that. Let me delete this connection. Split data will remain as it is. This algorithm will connect like this. Boosted decision tree, so it will be parameter range. Tune model hyperparameter, as I have not changing anything, it will remain. It will run on pricing. Score model 70-30, sorry, model and then 30% data. Evaluate. Now let us run this, and it is going to take another 20 minutes. It's running. It is still running. It's been 12 minutes. I guess this will take another 7 minutes. Let's wait for a while. This has been 20 minutes and it's still running. Let's wait for a while. And we see this is more than 30 minutes and it's still running. But boosted decision tree regression model, this actually takes time. And over that, we are hypertuning the model. Let's wait for a while. Well, now finally it has run. It ran for around 38 minutes. Let's visualize. Okay, so this was the first one, our very first model. Here we have 15 and 0.32, 0.16. 0.32, 0.16. So clearly this is the best model that we have. Let me mark it green. Let me remove this. So here we are using boosted decision tree. So if you see our progress, first we used decision forest regression, then we added a feature selection to reduce the number of features, then we tuned the model hyperparameters, and then we added new algorithm, boosted decision tree regression model with tuned model hyperparameters. And we see that this has the best result. So what we are going to do is we are actually going to deploy our model in the next session. But before that, I must save it. Okay, now it has saved. Either we can go directly deploy it. Before deploy, I need to run it one more time. Either we can directly deploy it, or what we can do, just to avoid future confusion, I can actually go ahead and delete this, and this. Or if you're very clear, if you don't have multiple models in your account, then you might just want to deploy it this, and you should remember that you are deploying which model and how we have progressed. Anyways, when we are going to deploy the model, it will ask which model do you want to deploy. At that time, we have to select this. I had also run, though I did not show you, but I had also run separately decision forest regression along with tune model hyperparameter, but the result was not better than boosted decision tree regression. So we'll go ahead and we'll deploy this model. So I'll see you in the next session, guys. Thank you so much. It was good connecting with you all. Bye.